This is question number 8 of homework 6. For chapter 6, you are given the following series of 1-year interest rates: 5%, 7%, 12%, and 12%. Assuming that the expectations theory is the correct theory of the term structure, calculate the interest rates in the term structure for maturities of 1 to 4 years and plot the resulting yield curve. So this is a very standard problem with regard to the expectations theory. So what this theory says is that bonds of different maturities, they are perfect substitutes. That means for a bond investor, as long as the average annual return of the long-term bond, for example, 20-year bond, and the annual return of the short-term bond, as long as the average annual return is the same, then investors actually they don't care about whether they invest in a long-term bond, 20-year bond versus that they invest in a 1-year bond. So that's basically what this expectations theory says. So you can pull out my lecture slides, which basically is a summary of the major points in this chapter. And expressing that perfect substitution into math, we basically have this formula. So this may sound a little bit daunting if you don't understand the mechanisms behind this. But if I just draw a chart, probably you can find it easier to understand. So let me just pull out my notes. So it's one note. Yeah. And let me open a new one. So this is so what this basically says is, okay. So let me use a chart timeline. So I have the so this is a 1 year and 2 year, 3 year, and 4 year. So this is interest rate for the 1 year, and this is the expected interest rate for the second 1 year, and this is the expected interest rate for the third 1 year, and this is the interest rate for the fourth 1 year. So let me just put down the number as in this question, so to make it more concrete. So this is a series of 1 year interest rates. That's basically first one is 5%. And the second one is 7%. So that's what it means by series of 1 year interest rates. And the third one is 12%. And the fourth one is also 12%. So notice here, only the first one 5% is the actual interest rate. The future ones, because they take place in the future, so when we stand here, we stand here at this point, we actually can only expect these interest rates, this future 1 year interest rates. So the 7%, 12%, 12% here are not actual interest rates. They are expected future interest rate. And so that's what it means by a series of 1 year interest rates. So now with this expectations theory, and notice all these interest rates here refer to a 1 year bond, right? So this is like an investor invests a 1 year bond and they receive a 5% interest rate after 1 year. And then they invest in another 1 year bond, and when they stand here, they expect that they can earn 7% when they continue to invest in another 1 year bond after the first 1 year bond has expired. So they expect to earn 7%, and so on and so forth. After the second year, they expect they can continue to invest in another 1 year bond, and expect the interest rate will be 12% for that 1 year bond, and so on and so forth. So that's what happens here. But alternatively, they don't have to invest in a 1 year bond. They can just invest in this 4 year bond over the entire 4 year period. So this is a long term. And this is 1 year. Obviously, this stands for the short term. So what this expectation theory says basically is, okay, so you can invest in a series of 1 year bond like what we said, but alternatively, an investor can also choose to invest in this. This is actually a 4 year bond in this case, a 4 year bond. So the maturity of the bond is 4 years. So they can choose to invest in this 4 year bond, and every year they can also expect to earn a certain interest rate. And based on that expectation theory, expectation theory basically tells us, we call this I, subscript 4, which stands for the maturity, number of maturities. And if you go to my lecture slides, couple lecture slides, see that INT. So T here basically is where you stand. So that's the time point that you stand. So when we stand here, let's say the initial point here, let's assume that's 0, 1, 2, 3, 4. So this is 0, 1, 2, 3, 4. So this initial point, that's what this T in that slide means. So I40, okay? That's where you stand. You stand here, and you stand here. I40, that's basically this, I40, because for the long-term bond, every year you're going to receive the same. Same interest rate, I40, I40. So every year I subscript 40, that's what you're going to receive by investing in this 4-year long-term bond. So what this expectation theory says is basically that now you will be indifferent because this holds this annual long-term interest rate, which is I subscript 40, that actually is an average of this 4 one-year bonds interest rate. So that means 5% plus 7% plus 12% plus 12%. Then take the average, because we have 4, so divided by 4. So that's what this expectation theory, expectations, says this. Of course, this is just one interest rate. This interest rate is the annual 4-year bond interest rate. But you could also invest in a 3-year bonds, right? The 3-year bond. This is a 4-year bond. So similarly, based on this theory, if you invest in a 3-year bond, what you have is basically I30. So what happens, let me continue to draw this chart. What happens is that instead of you have 4 years, now you only have 3 years. And this is 0, this is 1, this is 2, this is 3. And then every year you will receive can you guess what the symbol will be based on what we just talked about? Yes, I30. So this is I30. This one is not so beautiful. I30. Okay, so similar to what we did for the 4-year bond, if it's 3-year bond, then only the first 3 interest rates are relevant. So now the relationship based on the expectations theory between I30. Again, this 0 here stands for where you stand. You stand at this time 0, so that's why we have 0 here. When you stand here, Y1, T1, then look to the future, then you only have a 2-year bond. So I3. That's an average of this first 3 interest rates. So that's 5% plus 7% plus 12% and divided by 3, because now we only have 3 interest rates. So then you see what's going on here. So that's basically what this expectation theory says. The annual interest rate for a long-term bond is the average of the interest rates of a 1-year short-term bonds. So that's what basically this expectation theory says. And then if we understand that, the calculation of this question should be straightforward. Just you can either use a calculator, or if you want, you can also use Excel. Just put down the interest rates. So this is 5%. Why don't we, yeah, and 7%, 12%, and 12%. So this is a 4 years interest rates. I put down like that. And then if it's 2-year bond, like what we did, similarly, it should be what? It should be the average. So you can use the AVE function equals that average function. And then first one, second one, and then equals that. Obviously here you can just look at that 5%, 7%, the average is obviously 6%. And for the 3-year bond, this one is actually the average of the first 3 interest rates. That's 8%. Sometimes you have to be careful because by default, I believe the number of decimal places for Excel is 0, so that means it doesn't keep any decimal places. But sometimes my Econ Lab will require you to keep a certain number of decimal places, so you got to better to change that. And you can do that in Excel by right-click on the mouse at the cell that you want to do the change, or in this case, I just want to do the change for all the columns here. So I just click on this column and then right-click on this and choose Format Cells, and then percentage, choose a percentage, and then based on the requirement. I guess here, since it's a graphing problem, so it actually doesn't have any rounding requirements. So I just keep 2 decimal places for convenience. And finally, 4-year bond, as we said, that's simply the average of the first 4 years interest rates. So that's 9%. Okay, so now we have the interest rates for all the long-term bonds and as well as the 1-year bond, which is 5%, right? That's the actual interest rate for the 1-year bond. So with that, we can draw this plot. So one, using the point drawing tool, plot the interest rate, calculated using the data above for each of the 4 terms to maturity. Properly label each point according to its corresponding term. So the first one is 5%, so that's years to maturity, that's 1, and then that's 5. So let me use click on that, and you use the point drawing tool that's here, and that's this point here. So which one? That's obviously that's 1 year. And for the second one, as we just calculated here, it's 6%. So point drawing tool again, for years to maturity, that's 2. So this equals 6%. Notice here, this doesn't have to be very accurate. Yeah, that's another benefit of using this My Econ Lab. As long as your point is very close to the precise point, your answer will be marked as correct. So this is the 2nd year, and continue that 3rd year, 3-year bonds, the annual interest rate is 8%. So that's right here. So then choose the point tool, 8%, and this is the 3-year bonds. And finally, for the 4-year bond, the point drawing tool, that's the 9%. So from this, what shape of the yield curve can we say? Because the interest rates are going up with the increase of the maturity. So this is called a normal yield curve, normal shaped yield curve, or upward sloping yield curve, because that's the most common case. So choose the 4-year here. And so that's done for the first part. And second part, using the 4-point curved line drawing tool, connect these points, label your curve yield curve. So 4-point, so this is a 4-point curved line tool, starting from the first point, then second point, third point, and fourth point. You see that actually it's kind of curved, right? It's not just a direct connect these lines, it's a curved line. And we label that yield curve. So now let me check my answer. Nice work. Continue. how would your yield curve change if people preferred shorter term bonds over longer term bonds? So this expectations theory, as we said, depends on the assumption that investors are indifferent between the bonds of maturities as long as their interest rates are the same, their annual interest rates are the same. So that's the assumption behind this expectation theory. But if investors actually prefer shorter term bonds over the longer term bonds, then this assumption no longer holds. So if investors prefer a shorter term bonds, how could you attract investors to buy and hold longer term bonds? Because now they have a preference. Before they don't, right? They are indifferent as long as their interest rates are the same. Now, if they have a preference over the shorter term bonds, then the only way for them to be willing to buy and hold longer term bonds is to increase the interest rate offered by these longer term bonds. So when the longer term bonds interest rates goes up, what will that influence the shape of this yield curve? Obviously, that's gonna increase the slope, right? Because the slope means that the longer term bonds, they have a larger interest rate. And that's exactly what we expect when investors prefer short-term bonds. So the answer here should be become steeper, right? The steeper. Excellent.